Hey, I'm Spencer. I love thinking about space and I love talking about space, and so I'm going to share a lot of my space facts with you, especially here with my guided planet tour, where we're going to talk all about the various planets in the solar system. But to talk about the planets in our solar system specifically, we got to start with where our solar system is actually located, which is there. And what is there? What is that? Well, that is our Milky Way galaxy. A galaxy is a collection of space stuff. Think of anything, really, and you're going to find it in a galaxy. You know, black holes, nebulas, stars, planets, asteroids, comets, all that good stuff, houses, fish. That trash can over there is all in our galaxy, so it's all kind of fair game. But our Milky Way galaxy is called that because it looks like someone spilled a bunch of milk across the sky. Of course, that's not what actually happened. The white milky stuff is actually star-forming regions of the galaxy. They're giant space clouds made of space dust. And over millions of years, every molecule in the cloud pulls other molecules nearby closer to it, and so eventually the gas kind of shrinks down and it gets really small and compact, and it forms a very hot, dense thing we call a star. And so all the milky stuff that we see in the Milky Way, it's just stars that haven't been born yet. But thankfully, one of our stars have been born. It's my personal favorite star. It's this one right here. What is that star? Well, it's the sun. You may have seen it before. It's out in the day all the time, and our star is incredibly important. The fact that our sun is a star comes back to two main reasons. One, it's incredibly big, and the other is that it's incredibly hot. So how big is the sun? Well, it's kind of hard to think about because our brains are rather small, and it's hard to comprehend how giant and astronomical, literally, space is. But I can tell you a number. It's 1,000,000 times larger than the Earth. That's hard, though, because the Earth is already incomprehensibly big. To try and multiply that by 1,000,000 is very difficult for me to understand, but that size is really important. The mass of the sun is what keeps us all here bound in the solar system. The reason we're all orbiting around because of gravity happens because of how massive our sun actually is. And so even if we don't super understand it, it's still good to know that the size is incredibly important. But the temperature of the sun is also very important. How hot is the surface of the sun? Well, it's hard to think about because space numbers, again, very big. Is it thousands, millions, a billion degrees? I don't know. Well, the surface is not as hot as a lot of people imagine. It's only about 10 or 11,000 degrees Fahrenheit. That's obviously super hot. Like, I would not want to hang out in 11,000 degrees of Fahrenheit. But it's not as hot as a lot of people expect. That's just the surface, though. If you actually go a little bit further away from the surface of the sun, you venture into what's called the corona. It's the sun's atmosphere. And for some reason, the sun's atmosphere, the corona, it's actually hotter than the surface. And we don't super understand why that is. It's actually about 1,000,000, if not millions, of degrees Fahrenheit. And that's super, super hot, and we're still trying to figure it out. We've got some space missions right now happening as we speak, or well, as I speak, because you're listening, and it's happening, it's orbiting around the sun. It's trying to teach us exactly why the corona is as hot as it is. And the surface of the sun is also nothing compared to the center. The center gets up to about 27 million degrees Fahrenheit, and that's a staggering, absurd number. But it's actually really important because that's about the benchmark required for fusion to happen. At the center of the sun, the hydrogen atoms are vibrating around so fast. When they bounce into each other, they fuse together and they release a tremendous amount of energy, and that energy is obviously very important. The sunlight that goes from the sun gets absorbed by our plants, and then we eat the plants, and then we have the energy to talk about planets. And so the fact that the sun is as hot as it is, especially at the center, is the reason that we're all breathing and alive here on Earth. And so the size and the temperature, both incredibly important of the sun, but this is a planet tour, so let's start talking about some planets. Now, the first planet in our solar system is actually this one right here. It's called Mercury. You've probably heard of it. It's one of my favorite planets, the top 8 or so. Now, Mercury looks a lot like a thing you might have seen before at night, sometimes during the day. I think it looks a lot like our moon. And that's because Mercury and the moon, they have a lot in common. One, they're very small objects. Well, they're, planet-sized objects, but they're very small compared to the thing they're orbiting. Two, they look the same. They're big gray rocks. They're made out of the similar kind of stuff, silicate rock, a little bit of iron and stuff like that. But the really big similarity that people will notice are the craters all across the surface. You see hundreds, if not thousands, of craters on both Mercury and the moon. But why is that? Well, to figure it out, we got to think about why a crater happens, right? It happens whenever a giant space rock, an asteroid, smashes into a planet or a moon. It creates these giant holes that we call craters. But why doesn't the Earth have that many craters? We actually have a shield here on Earth that protects us. It's called the atmosphere. Like, you're all breathing right now. It's pretty good. I like breathing myself. We're breathing in air. It's the atmosphere that we're breathing in. So it's important for us on Earth to regulate our temperature, for us to actually breathe, but it's also protecting us from asteroids. Whenever a space rock wants to smash into the Earth, it gets a bunch of friction, it breaks apart in our atmosphere, and so rarely does a space rock ever actually hit the surface of the Earth. But Mercury and Venus, or Mercury and the Moon rather, they don't have any atmosphere, so they don't have a shield to protect them, and so they've got tons of craters, thousands all across the surface. But the really coolest thing that I actually find, the coolest similarity between Mercury and the Moon, is that they're spinning incredibly slowly, especially compared to the thing they're orbiting. So our Moon is tidally locked with the Earth. That means that one side of the Moon is always facing the Earth because it's orbiting and rotating at the same speed. We kind of know this a little bit because if you look at the Moon, it always looks the same. I mean, sometimes it's a full moon, sometimes it's a crescent moon, but it's always the same face, the man in the moon, right? And that's happening because one side of the Moon is always facing us as it orbits around. Now, Mercury is becoming tidally locked with the Sun. It's not quite there yet, but it does spin very, very slowly. And so its day lasts for dozens of Earth days. It stays day on Mercury for a very long time, and it gets really hot there, about 800 degrees Fahrenheit during the day. And that's expected. It's the closest planet to the Sun. Of course, it's pretty hot. But this also means that it stays nighttime on Mercury for a very long time, and that's actually really interesting too, because it gets down to about -200 or 300 degrees Fahrenheit on the surface of the planet Mercury, which is a bit counterintuitive, because you would imagine the closer you are to the Sun, the hotter you get, and that's true in general, but a little bit, the Mercury, even though it's the closest, it's also one of the coldest planets on some places. So really interesting, but I can't just talk about Mercury all day. There's other planets to get to. So let's zoom along to planet number 2. This one's called Venus, and you've probably heard of Venus because it's spectacular. You can also see it. It's one of the brightest things in our sky. It's actually the brightest thing other than the Sun and the Moon. So if you look up and see a really bright dot in our sky, you're probably looking at Venus. But why is it so bright? Well, one, it's incredibly close to us. It's the closest planet of all the planets in the solar system. And two, it's got an incredibly thick atmosphere, which actually makes it kind of the opposite of Mercury in a lot of ways. Remember, we talked about how Mercury has so many craters because it has no atmosphere. Well, Venus has way too much atmosphere. It's about 10 times thicker than what we have here on Earth. And so that makes it incredibly bright. But it also makes it incredibly dangerous to try and study or land on. So let's imagine that we jump in a spaceship and we fly ourselves over to Venus and we try and land on Venus. Well, what's going to happen to us in our spaceship? It's nothing good. One, we're going to melt because it's about 900 degrees on the surface of Venus, which is incredibly hot. It's about twice as hot as our ovens get. And so it's really, really hot over there because of how thick that atmosphere is. It's got a lot of carbon dioxide, and so it traps heat. It holds onto heat with something called the greenhouse effect. It's happening here on Earth as well, but thankfully we don't have nearly as much carbon dioxide, and so we don't have the runaway greenhouse effect like is happening on Venus. And so it's very hot, but it's also incredibly heavy. If you were to try to walk around on Venus, you'd actually get squashed like a pancake because it's kind of like being under the ocean. We here on Earth, we're used to the idea of atmospheric pressure. Every inch of our body experiences 14.7 pounds of force. Basically, we experience dozens of pounds of force pushing down on us right now. We're just used to it. We've been living with it since we were born. But on Venus, you get 1,000 pounds per square inch of pressure. So every time you try and take a step, you're going to experience tens of thousands of pounds crushing you. And it's just not good for anyone. So it's really hot there. It's really heavy just to exist. And also there's acid rain falling from the sky. So basically, I just don't recommend going to Venus. It's incredibly cool to study, but it's very difficult. But we have tried, we as humans. The US has never sent anything to the surface of Venus, but Russia actually did. They had a whole series of missions called the Venera missions. A couple of them crashed, a couple of them missed Venus entirely, and a lot of them melted. But one of them was actually able to survive for an entire 2 hours. Which doesn't sound like a long time, but it actually was way longer than they expected. And we actually got a picture of Venus, which is really cool. It looks like this. It's the surface of Venus. It looks kind of yellow and sulfury. Its surface is rocky, and that's pretty much it. We don't have many other images of the surface of Venus because it's just so hard to land there, even with robots, let alone humans. The last thing I'll mention with Venus real quick is that it's also spinning incredibly slowly, kind of like Mercury, but for a different reason. Because at some point Venus got knocked upside down. It's actually spinning the wrong way. Everything in our solar system is spinning in the same direction. It's going counterclockwise and it's orbiting counterclockwise and it's all very uniform. But for some reason, Venus is going clockwise. It's spinning the wrong way. We think something might have knocked it over at some point. We're not entirely sure. We weren't there. It was probably billions of years ago. But we're still trying to figure that out. And it's a pretty cool factoid. All right, let's zoom along to planet number 3. This one, actually, So I'm sorry, I don't know how this one got in there. I actually don't know what planet this is. It says here that this is Earth. Have you heard of Earth? Actually, now that I think about it, I have heard of Earth. It's where I am right now. In fact, we're all here on Earth, unless you're an astronaut listening to me, which would be very cool. Please let me know. Otherwise, we are all sitting here on Earth. In fact, we've always been here every day since we've ever been born. All life that we've ever found ever has come from this single planet. Why is that? Well, we have a couple of really key things on our planet that lets us live here. The biggest and most obvious one is all the blue stuff everywhere. It's called water. You probably experienced it before. Liquid water especially is incredibly important for life to exist. In fact, everywhere we find liquid water on Earth, we find life. And everywhere we find life, they seem to require liquid water. And so it seems not coincidental, the fact that we have life here and that our Earth has tons of water. It seems like they probably go hand in hand. And when astrobiologists or astronomers who study life, when they're looking for alien life, they're often looking for the presence of liquid water. And there is a couple of places where liquid water exists in the solar system, but that's a whole nother conversation. But it's not just the water here on Earth that lets us live here. We also have that really nice atmosphere that I was talking about. You know what kind of reminds me of that story Goldilocks and the Three Bears? Have you heard it before? In case you haven't, or if you just really want to hear it again, let me tell you real quick. So there's this little girl Goldilocks, right? She's walking in the forest, which is actually a really bad idea. You should never walk in the forest by yourself, but that's what Goldilocks is doing. Anyway, she's walking in the forest and she finds a house and she decides to go inside, which is actually a really bad idea. If you're alone in the forest, please just don't go inside of a random house, but that's what Goldilocks does, and she realizes that it's actually a house for bears, which is really bad. If you're a little girl walking in the middle of the forest by yourself, don't go inside of a random bear's house. But Goldilocks does, and she finds some porridge, and there's a lot of porridge. There's some that's too hot, and there's some that's too cold, and she doesn't like either of those, but then she finds that just right porridge, and she loves the just right porridge, and she loves the just right sized bed and all the other Goldilocks things that she finds. And that's exactly what the Earth is. We're just the right everything. We have just the right atmosphere. It's not too thin like it is on Mercury. It's not too thick like it is on Venus. It's just right. It keeps us warm and protected from asteroids, but it doesn't suffocate us and make us way too hot like it does on Venus. We have just the right amount of liquid water. We have a lot of liquid water for fish, and that's really cool, but we've got some land for us humans as well. We've got just the right moon at just the right distance, and of course, we are just the right distance from our star. We call this the habitable zone. You can see a picture of it right here. It is incredibly important because any planet inside of our habitable zone is theoretically the perfect temperature for life to exist, or for liquid water to exist at least, which we think is a requirement for life. And so if you're too close to the sun, it's probably going to be a little bit too hot. If you're too far away, it's probably going to be too cold. The Goldilocks zone, or the habitable zone, is just right. But what's interesting is the Earth is not the only planet in our habitable zone. There's actually a whole separate planet, one of my favorites, and the next one we're going to talk about, which is also in the habitable zone. It is called Mars. Mars is pretty spectacular. And one of the reasons it's my favorite is because we just know so much about it. We've been able to explore it using lots of different scientific instruments. We've had satellites and landers, rovers, and soon to be, hopefully, astronauts. But some of the really cool things that I love about Mars are, well, one, the fact that it's red. It's really the only red planet in the solar system, and it's like that because of something called rust. You may have experienced this if you ever leave a bike out in the rain, or you've seen a shed or an old building that's just been kind of sitting there in the rain for a while. It turns kind of brown and rusty. The same thing is happening here with Mars, because there's a lot of iron in the crust of Mars and a little bit of oxygen in the atmosphere, especially a long time ago. And when those things mix together, you get iron oxide, which is a fancy word for rust. And so basically Mars is a giant rusty planet, which is kind of cool. But also, Mars used to be habitable, like I was talking about. We think that there actually was liquid water on the surface, and we know that because of the rovers that we've sent there. We've got the Opportunity and Spirit rovers that we sent like a couple decades ago, maybe a decade ago at this point. We've got the Curiosity rover, and soon we're going to be launching a brand new rover called Perseverance, which I am personally incredibly excited about. It's launching in July if everything goes well, and it's going to be a lot like the Curiosity rover, but it's got a couple of new sciencey gizmos, and we're going to learn a lot about Mars with this new mission. But how do we know there's water there? Well, we've got these cool spectrometers and gizmos on the rovers that have taught us that there were lakes and rivers and maybe even oceans on the surface of Mars. But obviously nowadays that's not true. There doesn't seem to be any liquid water there at all. In fact, it's way too cold. I get a lot of people who say it might be really hot on the surface of Mars because it looks red. I mean, red things are normally hot. That's totally fair. But it's actually about negative 100 degrees Fahrenheit. It's actually very cold there. And so it's way too cold for water to be a liquid. If there was any water there, it would be frozen, like the ice cubes in our freezer. And so something must have changed on Mars. Mars must have been much warmer at some point for there to be liquid water at all, and we're not entirely sure what happened. We think maybe Mars had a thicker atmosphere at some point, and for some reason that atmosphere has gone away. It's got one, a very, very thin, wispy atmosphere with a couple of clouds, but not much more than that, not enough to hold on to heat with the greenhouse effect like we're seeing on Earth and Venus. So something changed on Mars, and we're still trying to figure it out. Hopefully the Perseverance rover will teach us some stuff, or maybe the astronauts that go there in like 20, 30 years will be able to show us some really cool new stuff. Anyway, there's so much to talk about with Mars, I just don't have time to talk about all of it, but there is one more thing I want to mention, which is this incredibly tall mountain right there. The mountain is called Olympus Mons, and it is very, very tall. Do you guys know the tallest mountain on Earth? It's Mount Everest. It's really tall, right? Has anyone been to the top of Mount Everest before? I mean, some people have. I personally haven't. If you have, like the astronaut thing, just talk to me, because astronauts are really cool, and people who've come to the top of Mount Everest are pretty cool too. It takes years of training, and weeks or months to even climb to the top, and there's like no oxygen up there, so it's really hard to breathe. Olympus Mons, though, is 3 times taller than Mount Everest. It's so big, it actually stretches through the Martian atmosphere. So if you climb to the top of Olympus Mons, it's kind of like you're standing on a planet and in space at the same time. That's how tall it is. If you live here in Florida or in Orlando, or even if you don't live in Florida, you may have been to Disney World and ridden on Space Mountain. Well, Olympus Mons is an actual space mountain. It's like super cool. And if you notice, there's actually a giant hole at the top of the mountain. So it's not just a space mountain, it's a space volcano. That's pretty cool. Anyway, I could just geek out about Mars all day, but like I said, there's other planets to talk about. So let's zoom through our asteroid belt and venture to the land of the gas giants. Now, gas giants are very different than the ones we've discussed so far. We've talked about Mercury, Venus, Earth, and Mars. Those are rocky terrestrial planets. Like, you can walk around and jump up and down on those planets. I mean, you shouldn't jump up and down on Venus because it's like really dangerous there and you'll suffocate on Mars. So like, don't go to those planets, but you could physically walk on them if you really tried. But that doesn't make any sense with these gas giants because there is no solid surface as far as we know to them. This one right here is my personal favorite of the gas giants. It is the hulking gas giant Jupiter. Now, Jupiter is just really, really big. It's, again, really hard for our brains to comprehend just how big Jupiter is. In fact, you could fit every other planet inside of Jupiter and still have room left over, which is pretty incredible. But like I said, Jupiter is a gas giant, meaning it's made out of gas, and you can't stand on it. It would be like trying to stand on a cloud. Like, you've never stood on a cloud, I assume, right? Unless you're some kind of like astronaut cloud walker thing, but probably not. And so you could not stand on Jupiter either. That doesn't really make any sense. And so it makes it very hard to study because we can compare Mercury, Venus, and Mars to our planet Earth. We're all kind of similar. But we don't know much about these gas giants. We do have a satellite in orbit around Jupiter right now called the Juno spacecraft. It looks like this. And Juno is one of my favorite space missions because it's teaching us about the mystery of Jupiter. It's trying to figure out what the core of Jupiter might look like. We don't know if it's solid or liquid, if it's hydrogen or iron, or really what it is. It could be metallic hydrogen, which is this weird physics thing that we're not even sure is real. So there's a whole bunch of cool science coming out of that Juno mission, but it's also got some really cool images. So I recommend everyone look up Juno images later because they're some of my personal favorites. They're incredibly high-resolution surface images of this Jupiter gas giant. They're really amazing, and just do it. They're really cool. You won't be disappointed. But everyone loves to talk about one of my favorite parts as well on Jupiter, which is that right there. That is a great red spot. Do you know what it's called, by the way? It's just called the Great Red Spot. Because like scientists aren't always clever when they name stuff. They just kind of call it what they see it, and they saw a really big red spot, and they're like, that's what it is. Let's call it the Great Red Spot. But the Great Red Spot is actually really cool. In fact, it's a tornado that has been swirling around for hundreds of years. The first person to ever invent the telescope was a man named Galileo. You've probably heard of him. He invented the telescope. He put a bunch of lenses together. He looked up at Jupiter, and he also saw a Great Red Spot. We think it's the exact same one that he saw way back then. And so it's 100 years old, or hundreds of years old, and it's also over twice as large as our entire planet. Right? I know, space is hard to think about. It's really, really big. But you know, the hurricane, or really the tornado, because there's no water involved, is only one of many. There are hundreds of storms all across the surface of Jupiter. And so, again, check out those Juno images later because they are super cool, and we have really awesome high-def images that you should check out. All right, let's zoom along to planet number 6. This is many people's favorite planet, except for Earth, but we're all a little bit biased. This is, what is it? Oh, it's Saturn, exactly. Saturn is really cool because it's got those rings, right? Now, I cannot project rings onto my sphere, but you can imagine, or you can see this picture right here. You know what Saturn looks like, though. It is a big, awesome gas giant, and it's got these really big, awesome rings. But what I find interesting is that hardly anyone ever talks about the rings around other gas giants. Like, we just talked about Jupiter, and I didn't even bring up those rings. But Saturn does have rings just like, or other gas giants do have rings just like Saturn does. It's just that those rings aren't as reflective. They don't have as much ice around Jupiter's rings and our last two planets. And so we don't see them from here on Earth quite as easily. In fact, we didn't discover Jupiter's rings until much, much later. But Saturn's rings are pretty spectacular. In fact, we've actually but we've commanded a spaceship to fly through the rings of Saturn like 1 billion miles away. Like, really think about what that means. We picked up a bunch of rocks and metal out of the ground, and we put them in a way that kind of worked so that it launched into outer space to that tiny dot in our sky that you can barely see with your naked eye. And it flew to that place, and it orbited around, and it dove through the rings of Saturn a few times. I think it's one of the coolest things that humans have ever done. But that also taught us some pretty important stuff. Like, Saturn is losing its rings. They are evaporating. And we're not really sure why it is, but we think it's probably falling into Saturn itself. But it leads to some pretty interesting conclusions. Like, maybe Jupiter had a much larger ring system at some point and it went away. We think that Saturn's rings might be gone within the next 100 million years. I mean, not something we have to worry about, but it's not going to be there forever. And so we might be incredibly lucky that we can exist at the same time as Saturn's rings do at all. They might be much newer than we realize, and they're probably not going to be here forever. So it's incredibly cool that we even get to see them in all their grand glory that we see them nowadays. Another cool thing about Saturn is that it has a really interesting storm as well. Not quite the Great Red Spot, but kind of different. It's actually hexagonal, if you can see it there. The North Pole of Saturn actually has this hexagonal storm, and for a while it really puzzled people. We had no idea, because you don't normally see hard angles in outer space. Most things are just round, right? Circular or oval shaped, or elliptical rather. But we had this hexagonal storm, and it was very perplexing. We had no idea how it was there or why it was there. And so we actually had to do some tests here on Earth to figure out what could create a storm like that. We did some tests with these spinning beds of fluid, and we actually found that if you spin at the right speed with the right kinds of fluids, you can actually create these hard angled hexagonal storms that we're seeing on Saturn. And so it goes to show that not all space science, not all astronomy is found from spaceships and telescopes. We have to actually do tests and simulations here on Earth to learn about outer space, which is kind of cool. Other than that, Saturn spins incredibly quickly, which is also kind of interesting. And so a day is much shorter on Saturn. It's actually spinning so fast that it gets squished down a little bit. Most planets are really, all the other planets are kind of spherical, but Saturn's a bit more squished and elliptical because of how fast it's spinning, which is kind of neat. All right, we've got two more planets to talk about, but we can really discuss them at the same time because our last two planets are actually very similar. So this planet right here is Uranus. Now, Uranus, or Uranus, or however you want to say it, is interesting because it's actually spinning on its side, which we'll get to, but I do want to show you our last planet as well, because like I said, they're very similar, and we don't know much about them. This one here is planet number 8. It's called Neptune. And you'll notice they're basically the same color. They're very similar in size. We call them the icy giants of our solar system. They're also kind of classified as gas giants like Jupiter and Saturn, but they're a little bit different. They're actually quite a bit smaller than Jupiter or Saturn, though they're also much larger than the terrestrial planets. So they're kind of in a class of their own. Also, they're very far away and have lots of ice, so it makes sense to call them icy giants, right? But like I said, the cool thing that separates Uranus from Neptune is the fact that it's actually spinning on its side. I mentioned earlier how everything in the solar system is spinning in the same direction. We're all going counterclockwise, except for Venus, which is going clockwise for some reason, and Uranus, which actually spins 90 degrees compared to all the other planets. It's kind of tumbling through outer space instead of spinning like all the other planets are. And just like Venus, we actually don't know why that is. We assume something knocked into it at some point. Maybe a giant star swung by and pushed it over with its gravity. Maybe it collided with another planetesimal like 4 billion years ago. We're not entirely sure, but for some reason Uranus is spinning on its side, and in fact its entire system is on its side. All of the moons of Uranus spin upwards, up and down vertically, and its ring system is also vertical as well, which is pretty interesting. And then the cool thing that separates Neptune is that it has the highest wind speeds of anywhere in the solar system, pretty much. It gets above 1,000 miles an hour, and that's actually important because it kind of tears apart any potential storms that would exist for any longer period of time. For example, if I swing this around here, we might notice that there's a great dark spot on there. Do you guys know what that's called? It's just the great dark spot, just like the great red spot, not always clever, just kind of calling it what we saw. We saw a big dark spot, and that's what we called it. It's kind of like the great red spot in that it's a hurricane, or more properly a tornado that's been spinning around for a while. But the difference with the dark spot is that it goes away every couple of years and kind of reappears somewhere else, whereas the great red spot's been floating there for hundreds of years at least. And we think the fact that it's going away is attributed to the fact that the wind speeds are so high on Neptune, that it's just much more chaotic and much less stable. And so we just don't see that same stable cyclone like we see on Jupiter and Saturn. But you'll also notice the cool color of Uranus and Neptune. They are kind of a blue, or in Uranus's case, a greenish blue. And some people might assume that's because of water, like we have here on Earth. Our Earth is certainly blue because of liquid water. But in this case, remember, these are icy gas giants. They're mostly made out of gas, and so there is no liquid water. If there was any water there, it would be very much frozen because of how far away these planets are. And so the blue that we see on Neptune and Uranus is actually a gas called methane, which is pretty cool. We see methane here on Earth as well. We don't see it. It's quite literally invisible to us. But we're breathing it in right now. You're breathing in methane right now. And so we have tons of it here on Earth, but not enough to make our atmosphere blue. There is much, much more methane on Uranus and Neptune, which is giving those bluish colors to the planets. Pretty neat. All right, now that is all the planets, but there is one more thing I want to talk about real quick because, well, when I was a kid, I learned there were 9 planets, and I assume a lot of our grown-ups did as well. Do you happen to know what this last 9th old not a planet anymore thing is called by chance? Oh yes, it's just Pluto. Everyone knows Pluto, right? Everyone loves Pluto. And in fact, a lot of adults are kind of sad about Pluto because we learned it was a planet, and then evil scientists changed their mind, and we're all upset because we don't like change. And I get it. That's totally fair. Kind of. But also, science is all about change. The fact that we've changed our minds, I think, illustrates what science is all about. We're always changing our minds about everything. We once thought the Earth was all there was. We didn't know about the universe. And then we learned the Earth is the center of the universe. And then we thought, that's ridiculous. The sun's the center. Well, no, the sun's only one of billions of stars. Well, actually, there are billions of galaxies. Anyway, we keep changing our minds about stuff. That's what science is all about. And so Pluto being downgraded to a dwarf planet, I think, is just one more step in that scientific adventure that we are all so happily on. But Pluto is still fascinating. You don't have to be a planet to be awesome. I love Pluto, even though it's considered a dwarf planet. And I think it's important to know why Pluto got downgraded. Again, I don't like that word, downgraded, because it means that it's inferior, but it's not. Dwarf planets are also really cool. So why did we decide to change Pluto's title? Well, about 15 years ago, astronomers were teaching their students, as astronomers do, and one of their kids raised their hand and they said, "Hello, Mrs. or Mr. Astronomer, what is a planet?" And the astronomer thought to themselves, and they're like, "What? Actually, hold on, what is a planet?" They realized, they flipped through their textbook and they realized we don't have a definition for a planet. This is horrible. We are using the definition that the Greeks had invented 2,000 years ago, which is very bad science. And so all the astronomers from across the world got together at the International Astronomers Union, and they came up with 3 rules that a planet has to follow, or an object has to follow, to be considered a planet. And when they came up with those 3 rules, Pluto did not pass the 3rd rule. So what are the rules? Well, the first is that you have to be big enough to pull yourself into a sphere. Because if you have enough mass, you're going to be shaped like a ball. That's the most energy efficient shape there is. Like when you blow a bubble, what shape does it make? Same thing, right? Like a ball, a sphere. And that's happening because the surface area is trying to be minimized. That's just how energy works. And so if you have enough mass, if you're big enough, gravity is going to shape you to be a ball. And that happens with tons of things. Most of the moons in our solar system are kind of round because of the gravity. And so rule number 1 is not quite enough. We have to go with rule number 2, which is that you orbit the sun. Now that sounds very simple, but that's what gets rid of all of the moons rather in our solar system, because moons orbit planets. They can't also be called planets. That would be just kind of confusing. So rule number 2, pretty easy, orbit the sun. Pluto does that just fine. It passes rule 1, it is round. It passes rule 2, it does orbit the sun. But it fails the 3rd rule, which is that you have to hold gravitational dominance in your neighborhood. You have to clear your neighborhood. And that's what Pluto does not quite do. You see, Pluto is inside an asteroid belt, not the asteroid belt that you've probably heard of. In fact, it's an entirely separate belt called the Kuiper belt. And Pluto shares its orbit with thousands of asteroids, if not millions, in the Kuiper belt. It also shares its orbit with Neptune. If Pluto was larger, if it had more mass, if it was gravitationally dominant, it would push those asteroids out of the way, or it would pull them into its orbit. But because it does not do that, because it does not hold that gravitational dominance, it does not clear its neighborhood, we just can't call it a planet. And that's totally fine. If we moved Pluto somewhere else where there was nothing else in the neighborhood, maybe it would be a planet, but that's just not the way the cookie crumbled. And like I said, it's okay that we call Pluto a dwarf planet because it's still awesome. It's got 5 moons, it's got these ice spears that grow out of the ground, it's got nitrogen glaciers. I mean, Pluto is spectacular. You're allowed to love Pluto. You should probably just stop calling it a planet. All right, I'm going to leave us with a picture of the size comparison of these planets so we can just see how big everything really is, or really how small some of that stuff is. We've got those first 4 tiny dots right there. Those are the terrestrial planets, Mercury, Venus, Earth, and Mars. They're really quite small compared to the hulking gas giants that are Jupiter and Saturn. Uranus and Neptune are no slouches of their own. They're also quite large, though just not quite as big as Jupiter and Saturn. And then you have that giant yellow monstrosity in the background that is our sun. Space is really big, and it's a lot to think about, but I love it because there's always something new to learn. I'm literally learning new stuff all of the time, and so I hope you can too. All right, my name is Spencer here at the Orlando Science Center. Thank you for watching.